Hello, yes, and welcome back to some mathematics. I hope you guys are doing well over this coronavirus containment. Okay, it happened again. So let me see if I can close out of this. Let's see what's going on. Close the window. Nope. Okay. Okay. So last time I did this, I had to do this. Then I hit this. Close. Okay, and now it's gone. Apparently, if I just hit it enough times, it goes away. Let's see if it pops back up later. This is going to be a fun adventure. Technology is being really weird as the district has installed a bunch of new things on our computers. And therefore, all sorts of software is going on. So you're going to have to bear with me. I apologize for that. I think I was saying I hope you guys are doing really well over this COVID-19 whatnot. Hope you're safe. Hope you're happy. Hope you're healthy. Let's see if this will still work or if I'm going to waste my time making a probably huge video and then it not work. Hopefully it works though, and then we can move forward from there. So I encourage you to look at this video before you start the Unit 4 exam that JCCC has now made available on Canvas. There are two parts to that exam. The take-home part is available now. The part that you'll complete on Canvas doesn't come available until next week, from what I understand. Now, that being said, looking at this, completing this on your own would probably be the best thing, and then using this video as a way to grade. So if you haven't done that, I recommend go ahead and try doing the practice exam on your own, and then you can grade it with this video like we would have done in class. But that being said, let's get started. Looking at number 1 here, convert 5 to the x equals 11 to the equivalent logarithm. So my base would be 5. My argument would be 11, and remember the logarithm solves for the exponent, so that would give me x in this case. Convert log base b of 15 equals 7 to the exponential form, so that would be b is my base, my exponent would be 7, and that equals 15. And that's it. That's all those problems are asking you for. All right, for problems 2 and 3, graph. All right, so we got -4 here. This is an exponential function, so that -4, oh my gosh, it's going to do this all the time. What if I just hit it 1,000,000 times? All right, and there it goes. Cool. Well, we're going to do that a bunch. I apologize, but until I really need to get this video done today so that you guys have access to it. So that'll probably just happen every problem or so. It'll be fun. Maybe we'll make a game out of it. All right, so -4 here represents the horizontal asymptote. Remember, since this is an exponential function, variables in the exponent. So that -4, 3, 4, I can just hit this. There you go. All right, now in my calculator, I'm going to say y equals 2 to the up caret, x plus 1, parentheses, x plus 1, close parentheses, and then -4, and hit graph. And as we can see here, that looks very nice. Now remember, when we're plotting these points, we want to be sure we get the intercepts right, and we want to be sure that we get the a certain amount of points. So second table, oh, this looks very nice. So let's go from -2 to 3 or so. So just create a little xy table here. Oh, xy. So -2, -1, 0, 1, 2, and 3. And when I do that, -3.5. -3, -2, 0. 2 is 4, and 3 is 12. So then I can just go ahead and plot these points. So -2, -3.5 would put me right about there. -1, -3 would put me right about there. 0, -2, 1, 0, 2, 4. There we go. And now I can connect my dots like so. Beautiful. All right. So we use the dotted line for the asymptote. We be sure the intercepts are accurately shown. If you want, it might not be a bad idea to go ahead and write the intercepts of 0, -2, and 1, 0, just to show that you really understand where those intercepts are. All right, so that's a graph of an exponential function. Now a logarithmic function. So for this one, we need to change a couple things up. Remember, for this one, it has a vertical asymptote. To find that, we can say x plus 3 has to be greater than 0, so x has to be greater than -3. So that means that vertical asymptote is going to be at -3. There's that vertical asymptote graphed right there. And I will say log, and I'm going to change the base formula of this, so I'll do log of x plus 3. Close that parentheses, divided by the log of 3. Now, if you have Math Alpha Math, you can just use that here. But for those of you who don't, you'll need to type it in like that. And I get something that looks like so. Excellent. So, second table, -2, 0, 0, 1. All right, so that's not bad for the xy intercepts here. Try to find some points here. So, -2, 0, and then -1, 0.63. Remember, those x values don't have to go necessarily right in order. So I'm going to see if we can get to where 2 is in our y value, 6, 2, and I'll call that good. So I got -2, 0, -1, 0.63, 0, 1, and then 6, 2. That'll put me right about there, and then I can go ahead and connect these dots. Be sure to show that graph going all the way down, right? If we look at our calculator here, it shows it stopping here, but we know that it doesn't stop. It just gets so close to that asymptote. So we need to show that when we graph it over here. All right, very cool. Evaluate each of the following. Log base b of b to the 5th. All right, well, that's telling me b to the what power gives me b to the 5th. So that's just 5. No work really required there. Log of base 7 of 33. So this is requiring us to use change of base here. So I'll do log of 33 divided by log of 7. Again, if you have Math Alpha Math, you can just type it in like so. 1.796. Of course, we're rounding to the nearest hundredth, so this would be 1.80. Very good. All right, next up. For 5 through 7, use the function e to the x plus 1 minus 8. E to the x plus 1 minus 8. Excellent. Find the domain and range. So it looks like there's going to be some graphing that goes along here. So let's go ahead and plot this in. So I'm going to do second e to the parentheses x plus 1 and then minus 8. All right, now I know since this is exponential that minus 8 is going to represent my asymptote. Remember that the domain of all exponential functions are always -infinity to infinity for exponential, of course. The range is, in this case, the going up from the horizontal asymptote, so that would be -8 to +infinity. The vertical asymptote, exponentials do not have a vertical asymptote, so we'll say none. There, the horizontal asymptote, however, would be y equals -8. All right, now find coordinates for the intercept. Show your algebra. Okay, so they want to find our x and y intercepts. E to the x plus 1 minus 8 algebraically. So y equals e to the x plus 1 minus 8 algebraically. So to find my x-intercept, I set y equal to 0. So I'll say 0 equals e to the x plus 1 minus 8. So to solve this, I'd add 8 to both sides. So 8 equals e to the x plus 1. And now I would need to, I'm solving for a variable in my exponent. I need to convert this to a logarithm. So this would be the natural log of 8 equals x plus 1, which means that x would equal the natural log of 8 minus 1. I can do that in my calculator. So I'll do the natural log of 8 minus 1, and I'll hit enter. 1.08. So my x-intercept here would be 1.08, comma 0. Very good. My y-intercept, looking at my graph, I know that a y-intercept exists here. Not sure, it'll be around something, but we can figure that one out pretty easily. So remember to find our y-intercept, we set x equal to 0. So y will equal e to the 0 plus 1 minus 8. Well, 0 plus 1 is just 1, so e to the first minus 8. E to the first is just e. So e minus 8. Close out of here, I'll do e, which for this case I'll do second division, minus 8. And hit enter. Negative 5.28. So, of course, I'll write it as a coordinate pair, 0, comma, negative 5.28. And there are our intercepts. Very good. All right. Let's move along. Number 8. We're going to do the same things now for logarithmics. Awesome. So, let's start by go ahead and graphing this. So I will do, okay, so this one's a little tricky. Let's throw in some parentheses here. So we'll do log of the argument, 2x minus 5, divided by log of the base, log of 2. Again, if you have math alpha math, you got the shortcut. Close that parentheses to show we're doing all the logarithm first, and then subtract 3, and we can graph it from there. Excellent. So remember, to find the domain, we can set the argument greater than 0, so 2x minus 5 has to be greater than 0, so 2x has to be greater than 5, which means x needs to be greater than 5 halves. So the domain would be 5 halves to infinity. The range, remember the range for these, for logarithmic functions, are always negative infinity to infinity. There we go. All right, now the vertical asymptote is at that same value of our domain, so we would say x equals 5 halves. The horizontal asymptote, there is not a horizontal asymptote with logarithmics. Remember, this is the exact opposite of exponential. And now find the intercepts. Okay, so I can look here at my graph. If my vertical asymptote is at 2/5, this is never going to cross the y-axis. So for y-intercept, I can go ahead and write none. For my x-intercept, I need to copy down this problem here. Log base 2 of 2x minus 5 minus 3. So I say log base 2 of 2x minus 5 and minus 3 is what y equals. To find my x-intercept, I set y equal to 0. So I would say 0 equals log base 2 of 2x minus 5 minus 3, add 3, so 3 will equal log base 2 of 2x minus 5. Again, it's asking us to show our algebra. We could do this in our graphing calculator just with a table, but it's really wanting us, or with second calc, but it's wanting us to show the algebra, so be sure we show that. So to convert this to exponential form, this would become 2 to the third equals 2x minus 5. 2 to the third is 8. 2 times 2 times 2. 2x minus 5, add 5 would be 13 equals 2x, which means that x is going to equal 13 over 2, or about 6.5, which if I'm looking over here, yeah, that seems pretty reasonable. So 13 halves, comma, 0. And that would be, there you go, my x and y intercepts here. All right, let's go ahead and check out number 11 here. So condensing logarithms into a single quantity. Excellent. So this is one where we really got to be careful of, make sure we understand exactly what's going on. So remember, if there's a value in front, that becomes the exponent. If it's addition, it becomes multiplication. Subtraction becomes division. So let's rewrite this first as log base 4 of x to the 5th plus log base 4 of 2z plus 1 minus that 3 is going to become the exponent, log base 4 of y to the third. Okay, addition becomes multiplication, so log base 4 of x to the 5th times, I suppose I could just write it like this, 2z plus 1. And then we have the subtraction, log base 4 of y to the third, and that becomes division. So my final answer here will be log base 4 of, in my numerator, I'll have x to the 5th times 2z plus 1. Boy, that was awful. I apologize for how terrible my handwriting works. I need a new pen. This one is broken. So we're working on getting a new one, but of course I can't go back to the building. All right, and I think that would be our final answer. So notice, we are fully condensed when there's only one logarithm. Log base 4 of x to the 5th times 2z plus 1 all over y to the 3rd. Excellent. Now, looking at 12, the exact same idea, except this time we are expanding, and it says to simplify when possible. And that's something that a lot of students always struggle on. So let's go ahead and split this up. Remember, if we have, well, let's split it this way first. So log base 2 square root of a b minus log base 2 of 16. All right, since that was being division. Now, in here, it's multiplying the square root of a and the square root of b. So log base 2 square root of a plus log base 2 square root of b minus log base 2 of 16. Now remember, taking something to the square root is the same as taking it to the 1/2 power. So that 1/2 needs to come in front of the logarithm now. Or we can divide it by 2 is another way of writing it. So you can say log base 2 of a over 2 plus log base 2 of b over 2. And now this one, log base 2 of 16, well, 2 to the 4th power is 16, so that means log base 2 of 16 equals 4. And that's when it meant simplify when possible. That's one that a lot of students forget to do, so be sure you're looking at that if they ask that on the test. All right, very good, very good. 13, solve each equation algebraically, exact answer only. So remember, exact means don't touch your calculator at any point. You should not touch your calculator. All right, so looking at 13 here, I need to start by isolating my exponential expression. So I'm going to multiply both sides by 2. So I'll have 4 to the 3x minus 1 equals 15 times 2 is 30. Now convert this to a logarithm. So log base 4 of 30 equals 3x minus 1. I need to add 1. So log base 4 of 30 plus 1 equals 3x. And divide by 3. Divide by 3. When I do that, I get x equals log base 4 of 30 plus 1 divided by 3. And that, my friends, is my exact answer. All right, no rounding, nothing. All right, 14 is asking for the same thing. Solve for an exact answer. So I got to start by getting this exponential expression all by itself. I'm going to subtract 8. So 3 times e to the 2x equals 17 minus 8 is 9. Divide by 3. Divide by 3. 9 divided by 3 is 3. So e to the 2x equals 3. Now converting this to a logarithm would be the natural log of 3 equals 2x. And then I can divide by 2 to get x all by itself. So x would equal the natural log of 3 divided by 2. Again, no rounding, no calculator. I never touched it. That's how I know I'm doing good. All right. This one's just to solve each equation algebraically, so it doesn't tell us exactly how we need to answer to leave our answers. However, these are logarithms. So remember, for logs, we need to check for extraneous solutions. Extraneous. Be sure we're looking for those. All right. So first step, we got to isolate this logarithm. So log base 4 of 7x minus 3. When I subtract 6 from both sides, 9 minus 6 is 3. Now rewrite this in exponential form. So that would be 4 to the 3rd equals 7x minus 3. Now 4 to the 3rd, I know what it is, but I just realized I haven't shown you recently how to use an exponent here. So 4 to the up caret 3, 64. Beautiful. So 64 equals 7x minus 3. And then I can add 3, so this will become 67 equals 7x. Divide by 7, divide by 7. That does not divide easily, so we can just leave it as x equals 67 over 7. Now, the question is, when I plug this in, am I going to get a positive number? And yes, I am, so I can feel pretty confident that that is the correct answer. Remember, that's us checking for extraneous solutions. 16 is multiple logs, which means we need to combine these to become one log. To do that, we can use those properties. So since we are adding, this can be written as multiplication. So log base 6 of x minus 3 times x minus 4 equals 1. So I'm going to need to multiply this out here. So log base 6 of x squared minus 7x plus 12 equals 1. And then from here, I can convert this to exponential form. So this would be 6 to the first power equals x squared minus 7x plus 12. Now, what type of an equation am I dealing with now? You got it, a quadratic. So let's get this equal to 0. Subtract 6 from both sides. 12 minus 6 is 6, so I'll get 0 equals x squared minus 7x plus 6, which I can then factor as x minus 6 and x minus 1. So that tells me then that x equals 6 or x equals 1. But I'm not done yet. Need to check for extraneous solutions. Look in here. Oh boy, 6. If I plug it in, that works for both. They'd give positive. This would be 3. This would be 2. But if I plug 1 in, 1 minus 3 is negative 2. 1 minus 4 is negative 3. Remember, cannot have negative values in our arguments, which means that x equals 1 is indeed extraneous. All right, so x equals 6 would be our solution here. Excellent. All right, got a few left. Let's see how we're doing. 17 and 18. Okay, for 17 and 18, it tells us suppose 15,000 is invested at an interest rate. No, not again. All right, just click it a bunch of times and it'll go away. There you go. Weird. Hopefully this is working. We'll find out, I guess. All right. Suppose 15,000 is invested at an interest rate of 1.6% per year. 17. What will the account balance be? What will the account balance be in 8 years if the investment is compounded monthly? All right. Monthly tells us we need to use the formula A equals P times 1 plus R over N to the NT, the compound interest formula. Monthly will tell me that N equals 12. 8 years is my T value. So let's plug it in. So all they want to know is the final value. So A will equal the principal, the initial 15,000 times 1 plus my rate as a decimal. So remember, so this would be 0.016 over N, which we just said was 12, to the 12 times 8 NT. And this is nice. I can pretty much just put this right in my calculator. 15,000 times 1 plus R over N 0.016 divided by N is 12 to the up carry. The important thing is that we put this all in parentheses. 12 times 8. All right, and when I press enter, I get $17,046.84. So A will equal 17046.84. There we go. Very nice. All right, now 18 is asking, after how many years would the account balance be doubled if the investment is compounded continuously? Okay, continuously means the continuous interest formula, aka our good friend PERT. All right, round to the nearest hundredth of a year. Excellent. So, how doubled? So double of 15,000 is 30,000. So 30,000 equals 15,000 e to the r, which is 0.016 t. And that's what we're solving for, because we want to figure out how many years it'll take. So we got to start by dividing by 15,000 on both sides to get our exponential expression by itself. That'll just give us 2 e to the 0.016t. All right, and then I can convert this to a logarithm. So the natural log of 2 will equal 0.016t. So divide by 0.016, divide by 0.016. And I find that the natural log of 2 divided by 0.016 equals 43.32. So it'll take 43.32 years for that amount to double, rounded to the nearest hundredth of a year. Excellent. All right, hope we're feeling good. We just got a couple left. 19. Oh boy. The population of Pewter City has been growing exponentially over the past years. This means, according to the model, A equals P to the RT. Thanks, guys. Its population was in 1998 was 14,450. Its population in the year 2015 was 19,200. Find the annual growth rate. All right, so this time we're wanting to find the growth rate, so that would be R. All right, so my final amount was 19,210. My initial amount was 14,450. E, throwing some Euler there. R, I don't know. T would be 2015 minus 1998, which is 17. All right, so let's start by doing some math here. Again, I would avoid putting this into our calculator until the very end. So I'm going to divide both sides by 14450. 14450. When I get that, I would get 19210 divided by 14450 equals e to the 17r. Convert this to a logarithm, so the natural log of 19210 divided by 14450 equals 17r. To get my answer, I would need to divide by 17, and this right here is what we can put into our calculator, all right? Notice we haven't rounded anything yet, and that's the goal. So the natural log of 19210 divided by 14450, close that parentheses, and then all of that being divided by 17, we should get a decimal here, 0.01674. So R equals 0.01674. Now think about this though. Remember the rate is written as a percentage, so we need to move this decimal place over a couple. All right, so 1.67% would be our rate there. Excellent. All right. Last one, number 20. The number of cells C of T in a petri dish are multiplying according to the model. There you go. Where T is the number of days after the dish was first observed. After how many days will the cell count reach 10,000? Round your answer to the nearest hundredth. So we want to find when the final amount, C of T, is 10,000. So 10,000 will equal 120 e to the 0.59t. Okay, so we're going to divide by 120. Divide by 120. Again, I'm not rounding anything yet. So I'll have 10,000 divided by 120 equals e to the 0.59t. Convert that to a logarithm, so the natural log of 10,000 divided by 120 equals 0.59t. Goodness, I'm running out of room. 0.59 divided by both sides. And that is what I can put into my calculator. So I'll do the natural log of 10,000 divided by 120, and then divide all that by 0.59, and I get 7.496. And this is what T equals, which means round your answer to the nearest hundredth, of course. So T will equal 7.50 days. And there you go. Those are our 20 questions. Hopefully you see lots of applications. Make sure we're feeling good about those. Make sure we know those formulas. Although, to be honest, you can totally look at your notes while you do this. Hint, hint. If you have any questions on the test, please feel free to email me, send me a message on Twitter, whatever it may be. I'm happy to help. All right, as we go back through this, a lot of graphing also, be sure we're aware of that. And then be sure we're just comfortable switching. And I think you guys will be really well set to crush this Unit 4 exam. All right, I miss you guys deeply, I really do. It's pretty tough being locked in our houses all days, but hopefully you guys are still finding a way to have some fun and get some math done. I'll talk to you soon. Mr. Carter, signing off.